Okay, now we're going to talk about graphing systems of inequalities. All right, and we've kind of done, this is a combination of what we've done before in the last section and what we're doing now with graphing inequalities. Okay, in the last section we were determining either algebraically, all right, by substitution or the elimination method or linear combinations, or by graphically, we're trying to find out where two lines intersect, and we're coming up with an answer, whatever it was. We had an x value and a y value for it. Okay, and the last section in this current unit, we were graphing a line and then shading a certain side. Okay, with this, with systems, we're taking one or two lines, or even three or more. Okay, we're going to graph them on top of each other. All right, so we have our two lines, and we're going to shade both of them, okay, and we determine where they intersect, just like we determined where two lines intersect here. All right, so we're determining where these two sections intersect, and our final result will be where the shaded region, the region that gets shaded twice. Okay, this blue region here. All right, so let's look at a couple examples of what we're going to do with graphing systems. All right. First, a good review. Okay, we're not going to review. We're actually going to just change this problem up. All right. I'm going to make this, and I know in your packet it says equal to. I'm going to make this less than or equal to, and I'm going to make this greater than or equal to. Okay, so we have x minus y is greater than or equal to 4. All right, I'm going to graph that first. X minus y is greater than or equal to 4. How do we graph this? Okay, well, in the last section we graphed this in slope-intercept form. Now we have standard form. So how do we graph using standard form? All right, when we have x and y on the same side. All right, we plug in 0 for x to find the y-intercept. And I'm going to change this to equals just right now for graphing sake. Okay? All right, plug in 0 for x to find the y-intercept. So I get negative y equals 4, so y equals negative 4. So my first point is at 0, negative 4 for this line here. 0, negative 4, plot a point. All right, I also have to find the x-intercept for this graph. All right, so x minus y equals 4. Change this to equals just for graphing it. All right, plug in 0 for y, and I get x equals 4. Okay, so 4, 0 is my second point for the line. All right, now I have 2 points. I'm going to draw a line through the 2 points. Okay, but in this case, and you guys might need more room to write down your work. All right, I'm just going to erase this. You guys don't erase it. I just need more space. In this case, I have x minus y is greater than or equal to 4. Okay, I have greater than or equal to, so am I going to draw a solid line or a dotted line? Okay, if it's equal to, remember it's a solid line. So I'm going to draw a solid line through these 2 points. Okay, now where am I going to shade? That's the next step. Oh, shaded, shade. Where am I going to shade? Okay, that's what I have to determine. All right, remember I said that if you could get 0, 0, use it. All right, I'm going to choose any point not on the line. In this case, 0, 0 is not on the line, which is good because that's the easiest one to use. And I'm going to plug it in for x and y in my inequality to see if it works. So I have 0 minus 0, x is 0, y is 0, is greater than 4. So 0 is greater than or equal to 4. Is that true? No. I feel like we're getting a lot that say no, but that's okay. All right, so this is no, so what I'm going to do is I'm going to shade the side that's opposite 0, 0. All right, so the upper left corner, I'm not going to shade. I'm going to shade this lower right corner because 0, 0 didn't work when I plugged it in. And at this moment, just to make sure you're listening, and what I want you to do is, on this line, I want you to put an L. All right, so we graphed that first one. All right, now we're going to graph the second one. So I need to erase all this. You guys leave it if you can. Okay, it's in standard form. 2x plus y is less than or equal to -4. Okay, and I'm going to graph it again using the intercepts because it's in standard form. So I'm going to plug in 0 for x and find the y-intercept, and I'm going to put equals just so that I know how to graph it. All right, this cancels. Y equals -4. So my first point again is 0, -4. I'm going to make this one blue. 0, -4 is right here. Same point as the first one. Okay, now I'm going to find the x-intercept for this line. Plug in 0 for y. 2x plus 0 equals -4. 2x equals -4. And we get x equals -2. So we go to -2 on the x-axis. All right, and that's our second point. I wanted to make that blue, right? Okay, so we have our 2 points. Now we could draw a line through the 2 points. Okay, what kind of a line are we going to draw? Are we going to draw a solid line or a dotted line? So let's look at our equation. Solid or dotted? Well, what's our inequality? Our inequality is less than or equal to. If it's or equal to, then we're going to draw a solid line. All right, now we have to shade. Plug in, find a point that's not on our line. All right, we could use 0, 0 again. It's not on our line. Plug it into our equation. 0 for x, 0 for y. Oops. 2 times 0 plus 0 is 0. Is less than or equal to -4? No again. Okay, so 0 is, remember, 0 is greater than -4. All right, it's better to have no money than it is to owe people $4. Okay, so now we're going to shade the side that doesn't have 0, 0. That's this side right here, the whole thing. Okay, and our answer, our solution to this system, all right, this system, these 2 equations here, all right, is where the 2 shaded regions are overlap each other. And what you might want to do is go ahead and get some colored pencils from me for this section. All right, so here is my solution, this overlapping region. Okay, let's go on to the next one. All right, now it says equal again. I'm going to change this so it's less than, just less than, not less than or equal to, less than. And I'm going to change this one to greater than. Okay, not greater than or equal to, just greater than. All right, so let's graph these 2. And these 2 are in slope-intercept form. Remember, y equals mx plus b. Y equals mx plus b. So we could graph it like it's slope-intercept. All right, I'm going to do this one first. I'm going to plot b, which in this case, b is -2. So go down to -2. All right, and then I'm going to use the slope. The slope is 2, or 2 over 1. Remember, we need rise and run. So I'm going to go up 2 from this point, 1, 2, and over 1 to the right. Both positive, so up and right. Okay, am I going to draw a dotted line or solid line? That's my next step. All right, I'm going to draw dotted this time because it's less than. It's not equal to. Remember, what that means is that if I were to choose a point on this dotted line, whoa, what happened there? If I were to choose a point that's on this dotted line, it wouldn't be included in our solution. Okay, the last step is to sub in a point not on our line, okay, and see if it works. Again, 0, 0 is perfect here. It's not on our line. Let's check to see if it works. So we have y is less than 2x minus 2. 0 is less than 2 times 0 minus 2. 0 is less than 2 times 0 is 0. Minus 2 is negative 2. Is that true or false? That's false. Okay, so that's not true. All right, so we shade the side opposite 0, 0. Now you guys could do a better job shading than I can, but that's fine by me. Okay, second problem. Let's graph it. We have y is greater than x plus 2. Let's graph this. Plot b. In this case, b is positive 2. And the slope is, right here, what's that? It's 1. All right, or 1 over 1. So positive 2. Let's do this one in blue. Positive 2 is my y-intercept, and I'm going to go up 1 and over 1. Okay? Now, do I draw a solid line or a dotted line? Well, it's greater than. All right, it's just greater than, so it's going to be dotted again. Remember, or equal to is solid. All right, so I'm going to draw a dotted line. And here's where making your lines as straight as possible is important. Okay. Now, next step is to see where we shade. So let's plug in 0, 0. Can we do that? Yeah, 0, 0 is right here. It's not on our line. All right, 0 is greater than 0 plus 2. 0 is greater than 2? No. All right, so we don't shade that side, so we shade everything else. Now here's where drawing the line is very important, because if you see, the overlapping region is just this little sliver right here. Okay, and that would be the answer to our system. All right, there's another video on the notes for this section. Go to the next video. Okay, bye.